everyone.
Yeah.
My name is Harrison Muchnick, and I've created a analog neural network hardware accelerator. I'll get into the demo in a second, but essentially what this allows is neural network inference at near the speed of light and at power magnitudes, orders of magnitudes, more power efficient. Applications I see for this are edge servers, drones, and robotics, where you still have your digital computer, your CPU, but you can send your inference jobs off to this hardware accelerator, and the neural network results will be returned back to the CPU. So if I run this program here, basically what's going on here is it's generating a random neural network, random biases, random input vector, and it's also creating that same circuit using the circuit design I came up with. So what this is basically a proof of is if for a given input, the output is the same for both the neural network, which has inference done the traditional way, as well as the simulated circuit, then this validates the design itself. And as can be seen here, here are the weights, here are the biases, here's the input vector, and the difference is 0. If I run this again, it generates new weights, new biases, and the difference here is 0.000002, something like that, basically 0, every single time I do this. This is something I've been developing for more than a year. The guys at UC Berkeley provide me with their SPICE circuit simulator, and that's as close as you can get to real circuit simulation. So this is pretty good validation for the proof of concept, and next step is actual fabrication of the circuit, which I'm very excited about.
How did you come up with this idea? I mean, it's really cool.
So I have a background in computer engineering, which is basically electrical engineering and computer science. So I had a lot of exposure to AI as well as electrical engineering. So this was kind of just a culmination of both of those fields that I put together. And after a lot of trial and error, I mean, I made it, so I'm really excited.
Omega bias for obvious reasons. How do you plan on getting this out to the world?
So obviously you need funding for the fabrication. The design itself is ready. I would print it out on a PCB.
No. How do you get people to want it, to understand its values? Like that, you're talking about the mechanics of like how you build the thing. I'm talking how do you sell it?
Right. So I mean, the results will speak for themselves. For instance, if you have a drone and you need to detect humans via a live camera feed, that's a very power-sensitive situation. You can't be running like a neural network on a regular computer, because that will use a lot of power. So if you have this hardware accelerator on board, you can just use an API that we will develop, send those inputs to the hardware accelerator. It will run the calculations at almost the speed of light, and then it will return the neural network results back to the.
So that's still not telling me how you're actually going to sell it, though. You need to put on your sales hat and take off your engineer hat. Like, it's just one of those things where, like, when we see a lot of things. Like, it's what I call like the field of dreams startup. Just having the best technology does not mean that they will come. And so you need to think through like who wants this the most. Who should I start with? And then how do I message out to them the ease of adoption and how it is that I'm gonna sort of get that in their hands?
Okay, I mean, I hate to be grim, but I do know some people who are in Ukraine right now.
Yeah.
They create extremely low-cost drones every single day, and they would directly benefit from this technology in being able to identify tanks, people, anything without a human actually having to look at the camera feed and identify these entities. So that is a direct trial group that I can easily onboard this with.
Yeah, that's incredible. You should.
So actually, I'm very interested in this product because I used to work for HFT, and so I personally use neural network to generate trades and stuff. So I'm just curious, how big of a model can you load on your chip, and how do you compare, let's say, the speed between let's say, for example, by using an open source TPU or a FPGA compared to your chip?
Well, if you're using a TPU or a GPU, it uses much more power because it's a more generalized device, and you have to deal with the clock speed and essentially just having things that are extra that are superfluous to a very primitive task. So if you think about a neural network, it's just a very simple series of mathematical operations. So you don't really need this generalized GPU or TPU to do that. You can just run it through a circuit, convert those output voltages back to your normalized values, and then that's essentially the same as just a neural network output, which is just a vector.
One last question.
Hi, yeah. So if this is a novel technology, who are your incumbent competitors? And I think this is kind of going back to his question, which is, I see this as very much like a dual-use technology. What would be the commercial applications or the DoD tech applications? And who are your competitors in either of those spaces?
So there's no one who's really created a commercialized version of a analog neural network. There are some companies out there that create PCBs on demand for specific applications. This would be the only one where it's modular in that it can be expanded without adding additional complexity. You're really just adding additional what I call unit blocks to it for any dimension of neural network. If you want to use other architectures such as recurrent neural networks or convolutional neural networks, that is not something that I have created design for yet. So this is just purely neural network. You have a vector input, it runs through the system, and it gives you a vector output. And you can do with that whatever you want.
Yeah, cool stuff, by the way. And first question, you've got a lot of research on designing very small LLM models that you can deploy directly on the chips. How does that compete with your stuff? And secondly, how can you scale your product there?
I'm sorry, could you please repeat the question?
Yeah, the first question was, there's a lot of research on deploying small model LLM onto the chips directly. How does it compete with your stuff? And the second question is, how can you scale?
So to address the first question, this is not for large language models. This is for a neural network. Neural networks, they're included in the architecture for large language models. They're a fundamental component of it, but this is not, you would not want to run a large language model on this because the scale of large language models is just orders of magnitude larger than a neural network for detecting if there's a cat in an image or not, or something like that. So the amount of design and effort that would have to go into making something like this work for a large language model is out of scope right